Hey, Professor Reza, it's Harlan Ferguson, student number 1011333838, and this is my submission for assignment number 2. So I just did it in the collab here just because you already prepared the assignment so nicely. It was already nice and organized, so I just decided to just continue on here. The first step is just to store where the file is located to the variable file name. So nice and easy. So I just uploaded it on the side there. Oh, you know what? I think because the last session I uploaded it and it's not there anymore. So let's just. Oh dear, it is. Is it not here? Hello? Oh no, sorry, it is here. Okay, my apologies. So we have it in the collab here. And so I just get the path to it and then store it to file name. And then what I'm going to do is I'm going to import pandas as PD, and then I'm going to read the CSV, turn it into a data frame, and I'm storing it under iris. And then for the question number 1C, we just want to print the head. So as you can see, we're getting them, and just as expected, we're only seeing Setosa just because that's how the data frame is currently organized. So now moving on to number 2 here. So what we want to do is just convert the strings to integers. So what we're checking is we're going to map a function that if we have Setosa, we map it to the integer 0. If it's versicolor, we map it to the integer 1. And Virginica, we map to 2. So we just do that and just change that column there. And when we reprint the head, you can see that we now have it displaying all zeros. Again, just because that's how the data frame is organized. If we look at the tail, I don't use Colab. Most of your assignments, I just use VS Code. So I forget that I have to, if I'm going to make changes like that. There we go. So if we look at the tail, you can see we're getting 2 now for the species. So we know that everything is working correctly. So I'm just going to change this back to the head as per the assignment instructions. And now what we're doing is we're trying to isolate the data and the labels. So with this, we're getting every column except the last one. So this works for this data set, but this isn't really a reusable code. And then for the Y, we're just getting the last column here. And then moving into 4, we need to split the data. So I'm going to make my imports to get train test split. And then we're making 4 different variables, the X, train and test, and the Y, train and test. Using X and Y, we're doing a 20% sample size as per what the assignment would like. And then I set the random state to 123 as asked to. And then similar to the data set, we're now just printing the head again. Let's see, we're getting those for the train and the test. And then for the Y train and Y test. So everything's looking good there. We're then asked to print the length for 4C. So we see we're getting 120 and 130, and just like in the assignment instructions, if we were getting 120 and 130, we are awesome. So we're going to move on here. So we need to one-hot encode the Y train and test. So I import TensorFlow, and then I make 2 new variables here, one hot for the labels, one hot for the train labels, and one hot for the test labels. And then we just use the Keras utility to categorical to do that. So that's all just built in, all nice. And then for 6A, we're asked to define a sequential model, use 3 dense layers, use 100 neurons or hidden units in each of the first 2 layers, and then narrow it down to 3 using activation ReLU for the first 2 layers and the softmax for the final layer. Now, once we set all of that up, we go to compile the model. We're using RMS prop as the optimizer and categorical cross entropy for the loss. And then we're just going to go ahead and fit the model here. We have it set to 20 epochs, so we should see that it runs through all 20. And it looks like we're getting a pretty good accuracy and loss ratio. So now we're just going to look at it with the model.evaluate function. And we can see for this, we're getting an accuracy of 86%, which isn't actually great. The first time I ran this, I was getting 96. So that's interesting as to why I'm getting a different value, even though I'm using the seed, like the random state, 1, 2, 3. It might just be because the first, yeah, let's rerun that. Yeah, way better. So I think just the first iteration of the epoch, since it starts at a random point, I just started on the lower end versus the higher end. So we can see this time around, I started right at 95, which is fantastic. So I'm now getting a 96% accuracy. But that just kind of goes to show that if I can get 86 once and 96 again, the model in its current state isn't as, don't know if optimized is the correct word, but it's just not as fleshed out as it needs to be. So clearly more can be done here. And then for 9, we're asked to do the same thing, but instead of having 100 neurons per layer, we're reducing it down to 10. And then we're also reducing the epoch from 20 down to 4. So I just make a new model number 2 here, keep it nice and simple. So it's just pretty much copy paste the other one, but just changing the epochs and the neurons there. So if we run this with 4 epoch and we get our score, you can see we're only getting an 80, which again is better than what I was getting previously, quite a bit better. But that's just most likely because, again, the random state on the first epoch. But yeah, we're getting 80 in this case, which is still not as accurate as the first model, but also not terrible. So then my answer to question 10a, I have lowering the number of neurons greatly affected the performance of the model. So it did greatly affect it when I first wrote the assignment. I was getting 60%. Now we're getting 80. So maybe it just affected the performance. But I don't think that it's an issue with the data, but rather just the result of the model being less complex. With fewer neurons, it's harder for the model to detect patterns in the data to make accurate predictions. In this assignment, I don't think we encountered overfitting because we achieved high accuracy on both training and test sets, which suggests that the model generalized well. For data like this, it appears that only 100 samples are enough to effectively train a model. However, for a more complex data set or one with more sparse data, we would need more samples for the model to establish the connections between the values and the labels effectively. If we do encounter overfitting issues, we've learned in class that instead of just splitting the data into train and test samples, we can also include a validation set. So we would split the test and take a chunk of the test to make it into a validation. This approach helps mitigate overfitting by providing a way to test the model on unseen data during the training process, thereby ensuring that the model's performance is generally reflective of its ability to generalize new data. So pretty much, I think like the IRIS dataset is, so I think we also just spoke about this in class, either this semester or last semester, but it's a baseline dataset just because of how clean and perfect it is. So it's very common to get just high accuracy when training models on it. And it's a relatively small data set, like only 100 rows is not too big. So kind of it's hard not to get a high accuracy. But that being said, you don't want to make a model too complex. So then what I did in 10b, so when we had model 2 here, I gave it 10 neurons with a 4 epoch. And then for my testing, what I decided to do, make another model, but just to double the amount of neurons per the layer, nice and simple. And then I also went and doubled the epoch as well from 4 to 8. So if we fit this, and then we go, we're now getting an 83% accuracy. this is interesting because again, I'm getting different values than when I first did the assignment. Because when I first did the assignment, I was getting really poor results. I was getting like a 60, and then when I ran this, I was getting a 90, and I was like, easy peasy. But I'll read what I wrote, and then I'll maybe just reflect on why this is different now that I'm recording it. So for my first test, I took a poor performing model, doubled the neurons in epoch, which resulted in the same accuracy as the first model that has 80 more neurons per layer than my double neuron test model. So pretty much I'm getting the same performance as our first model with a lot less neurons on the layers. So this shows again that the data isn't super complex enough to necessitate a complex neural network. We were able to get higher accuracy by simply increasing the number of neurons and the amount of epoch. So yeah, the accuracy still is kind of awful. But when I was playing around with it, it just seemed like as long as you increase epoch, you just get a good accuracy. So I just went from 8 to 12, and now I'm getting 96 again. And 96 seems to be the highest that I can get, so there's probably some kind of not plateau, but just like you hit this without doing lots and lots of optimizations on the model. Like everything out of this is pretty just clear cut and not much tweaks to the actual model itself. But we're getting 96 by simply just increasing epoch. Like even if what was the original one again? So the original one was 10. I'm kind of just doing this for the first time since my notes don't reflect what's actually happening on the video here. But if I only give it 5 neurons, yeah. Oh, no, I need to rerun this. Okay, that's awful. Maybe it's not the best idea to do this testing as I'm recording. Yeah, because now I'm just getting terrible stuff. So there's not enough layers, so there's simply not enough to recognize any kind of pattern. You're just setting the model up for failure. So what if I just give it a bit more neurons here? There, okay. So yeah, even with 10 neurons, we were getting originally 80, and then simply by just increasing the epoch, we're now getting 93. So again, just kind of showing that it's a very simplistic data set and a very simplistic model, and it's very easy to achieve high scores on it. So thank you very much for watching. Apologies for at the last minute there, kind of just coding on the spot, but I just wanted to kind of show that I have learned from this assignment. So thank you very much. Take care, Professor.